Alright guys, in this video we're going to be reviewing logarithms and their properties. So let's start off with what a log is. Logarithms look like this, but our minds are more apt to think in terms of exponential functions instead. So this log equation can be written like this if you want to rewrite it as an exponential function, where this is the number that is being raised to a power. The power that you're raising that number to is the thing that the log equals, so it's a to the power of x. And the outcome of the exponential function is y, so that would be what goes here in the log. So, for instance, if I were to have log base 2 of 8 equals 3, we would write that as 2 to the third power equals 8. And so based on this definition of a log and its relationship to exponential functions, we have these properties. So anytime this base matches the number that's here, the outcome is 1. Or if this base matches this number here, the outcome will be the exponent. Anytime you have a log and this number here is a 1, the outcome will be 0. Anytime you have an exponential function, where its power is a log whose base is the same thing as the number you're raising the power of, the outcome will simply be whatever's here, which is x in this case. Another thing to keep in mind is that logs can't have 0 or negative numbers here. They're undefined in those cases. Some other things to keep in mind is that if you ever see a log that doesn't have a base written, what that means is that means it's a log with a base of 10. Or if you ever see an ln, what that means is it's a log with a base of e. Okay, so those are some log properties to keep in mind. And so here's some exercises to help you practice the properties of logs. Now, I'm not going to do any of these. If you need to see some examples, you can look in the 9.3 notes from previously this year. The reason I'm not going to do these is because once I do one, there's really no practice afterwards. I did it. It's not like I can make another one that's like that, so to speak. So I'm just going to throw them at you guys, and you can use the properties, or you could look at your 9.3 notes and see if you could deduce it. But we're going to move on to the next part, though, for numbers 7 through 18. I'll be doing the odd ones, and you guys can do the even ones. And we'll look at some more log properties to help us with those. So let's take a look at those properties now. So for these properties, you could either go from it being expanded in 2 logarithms to become 1 logarithm, or you could do it the other way, where you start with it as 1 log and you break it up into 2 separate logs. And there's 3 properties that allow us to do that. So anytime you have 2 logarithms, they have to have the same base number, which they do. 2 logarithms that are being added together, you could take this piece here, which is called the argument, and multiply those arguments together and put it in 1 log. So addition becomes multiplication in a sense. You can think of it like that. Or if you have 2 logs that are just being subtracted, in that case you will divide the arguments. Whichever one is first is the one that goes on the top. So log m minus log n becomes log of m divided by n. And if you ever have a log, when you have a log that is being multiplied by a number, that number can be rewritten as an exponent on the argument. Okay, and so those are our 3 log properties that we're going to use for the next set of problems we'll work on. All right, so here's number 7. What we want to do on number 7 through, what is that? 7, 8, 9, 10, 11, 12. 7 through 12 is we want to condense these expressions down so that it has only 1 logarithm in them. All right, so the first thing I notice is that I have a logarithm here that's being multiplied by 18. Using the third property on that last slide, we can make that 18 become a power on the 12, like so. We could do the same thing here with this logarithm. It's being multiplied by 3. so I can rewrite that one as 5 to the third power. Another thing that we can do is, since I have two logarithms now that are being subtracted, we could rewrite that as a single logarithm, where the 12 to the 18 is the numerator and the 5 to the third is the denominator. And we're not going to apply those powers. The numbers would be too big, so this is good enough. But there you have it. All right, so that's condensing using a couple of properties there. Let's take a look at another one. So number 8 is an addition problem. Number 9 is a subtraction problem. Let's see here. All right, so I changed number 8 so that it's a subtraction problem like the one I had there. So you guys can do 8. Let's move on to number 9 here. I'm going to start off in a similar fashion. We're going to take this multiplier here and make it a power on the argument. Same thing with the 4 here. That could become a power on the y. And now this one's different, though, in this case, because now we have addition. And when you have addition, we could put those two logarithms together as one log, where we multiply the arguments together. So that would be the answer, number 9. Number 10 should be like that, so I'll let you guys do number 10, and we'll move on to number 11. Number 11 is interesting because there's that fraction-looking thing there. How we're going to handle that is we're going to rewrite it as 1/2 times log base 2 of x. Dividing a log by 2 is the same thing as multiplying a log by 1/2. So we're going to rewrite that way. Now that I've rewritten it as a multiplication of a log by something, we can apply that property where we make those multipliers become powers. All right, and then finally, since we're adding those logarithms together, we can rewrite it as multiplication. Now it's possible that since we have a fraction power, the answer might be written a little differently. It might be written as a square root, because that's what a fraction power is. All right, so that would be number 11. Number 13 is pretty similar. I'm sorry, number 12. So I'll let you guys do that one, and I'll move on to 13. Now 13, we're going to be doing the opposite. We're starting with a single logarithm, and we want to expand it out so that it's separate logarithms. So notice, first of all, that we have 3 things in the argument that are being multiplied together. And according to one of our properties, the parts in the argument that are being multiplied together can be separated as logarithms that are being added together. Like so. The next thing that we can do is anytime your argument has a power on it, it can be rewritten as a multiplier of the logarithm. Like so. And that would be our final answer there. All right, so you could split the logs up as well. Let's go ahead and see if we can find one for you guys to do. Number 14 is for you. And we'll move on to number 15. All right, in this case, my argument has 2 things that are being divided. And in that case, you could split that up as 2 separate logs that are being subtracted. And since they both have powers, those powers can come to the front as a multiple. And that one's done now as well. So that's an example that has fractions or division in it. And there's one for you to practice. And then finally we have number 17. Number 17 has some square roots in it. And so when it comes to these square root problems, the first thing you're going to want to do, it's not a square root actually, it's a cube root. First thing we're going to do is we're going to change it to a power now. So a cube root is a 1/3 power. Now that 1/3 power is applying both to the x and the y. So I'm going to go ahead and distribute it in there. So we have x to the 1/3 and y to the 1/3. And so I basically have three things being multiplied together now in my argument. Z, x to the 1/3, and y to the 1/3. And anytime you have your argument consists of things that are being multiplied together, you could split them up into separate logs that are being added. Now anything that has an exponent, you could take those exponents and move them to the front as multipliers. And technically that's good enough, but another way that we could write this is we could write it as log base 8 of x over 3. Same thing there. So either one of these last two lines are good ways to write the answer. All right. And then there will be one in there for you guys to do for number 18. Just bear in mind yours is a square root, which means that even though the number is not written there, it is a 2. All right. So that's it. Hopefully that was helpful, and we'll see you guys later.